Today we're going to talk about proportional relationships. Proportional relationships are ones that increase at like a fixed rate. They're somehow related. So when one goes up by a certain amount, the other one will go up by a corresponding amount. So for number one, we have a problem here. A tree grows 2 feet every year. So we have time listed in years and the height of the tree. So after 1 year, if a tree grows 2 feet every year, the tree would grow, the height would be 2 feet tall. Okay? Again, every year it's growing 2 feet, so 1 year we have 2. 1 year later, we'd add another 2 to that and have 4. Another year later, we'd add 2 to this, we'd have 6. And after 4 years, the tree would have grown 8 feet. Now, when we're talking about proportional relationships, the way that we're looking at to figure these out without graphing is we're going to set these up as fractions. Okay, so let's try putting our time on top and height on the bottom. So this first one, time on top and height on the bottom, we have a fraction of 1/2. Now we want to know if these other ones are all going to be equal to 1/2. So how about 2/4? If we want to simplify 2/4, we divide both of them by 2, right? We want to simplify this down to 1. 2 divided by 2 would give us 1. 4 divided by 2 would give us 2. Okay, so these two are both equal to 1/2. I'm going to put a little check there. And we've checked those. How about 3/6? Okay, we're going to divide that by 3. It's going to give us our 1. We have to do the same thing on the bottom. Divided by 3. It's going to give us 2. 1/2. Again, corresponding. All these fractions are breaking down to the same rate. Every year, 2 feet. And 4/8. You guys might have a clue where this is going to go. If you want to get 4, turn it into 1. We divide by 4. Give us 1. Do the same to the bottom, which is going to equal to 1/2. Okay, these all corresponded. We just set the fractions up the same way. In this case, we always had time on top, height on the bottom, and we simplify them. They all simplify down to 1/2. This tells us that it is proportional. So let's look at another example. Okay, so now we have Tom's lap time. Tom ran 3 laps, and we have his time at the end of each lap. After his first lap, it was 40 seconds. By the time he completed his second lap, he was at 100 seconds. And after his third lap, he was at 80. So I'm going to set these ones up with time on top and lap on bottom, even though it's opposite on the chart. So our first one, we had a time of 40 seconds, and he finished 1 lap. I will just leave that one set up like that. We can't simplify this anymore, right? It's just 40 seconds per lap. This one, we would have 100 seconds for 2 laps. This one we can simplify. We're going to divide it by 2. 2 divided by 2 would give us 1, right? 100 divided by 2 would give us 50. Now, 40/1, 50/1. Are these the same? They are not. So we know that this is not proportional. This lap took 40 seconds, this lap took 60 seconds. Okay, these laps, he's slowing down. So let's find out the third one. We have 180/3, which again, simplifying this, you would take 180 divided by 3 and get 60, and 3 divided by 3 would be 1. Does this one correspond with the other two? No, it doesn't. This lap took even longer. So his laps and times are not proportional. We can't just say every lap he's running in 40 seconds. His laps appear to be getting slower at a varying rate. So in this case, they are not proportional. So we can say that 40/1 is not equal to 50/1. It's also not equal to 60/1. So that's how we can show that they're not proportional, because they should break down to the same ratio if they were proportional.